Hi everyone, this is Sangeeta, working as assistant professor in IoT department. This session I'm going to discuss about DHCP protocol. DHCP is nothing dynamic host configuration protocol, which means when the new device is connected in the network, it is in the need of service provider to provide IP for that device, right? So for that, we have to assign IP address for newly connected node in the network. This could be managed by DHCP protocol. So here we discuss about how it works, how it looks, and then what are the roles are there for DHCP. We will discuss in the session. Okay. So here the introduction about DHCP protocol. So the dynamic host configuration protocol, which is used to simplify the installation and overall maintenance of network computers. So networked computer means what are the node are interconnected together in the network that should be maintained and installed and deconfigured by dynamic host configuration protocol. So the earliest version of this kind of protocol is we can say it is a bootstrap protocol. Bootstrap protocol is the one kind of protocol which is also used for assigning IP address manually for the connected nodes in the network. So this Ethernet address are configured into network by manufacturer. It's a unique address. So logically, if we want to refer the device, we need three kind of addresses, right? The previous sessions where I discussed about where what are the different type of addresses are need to identify the node of the network, right? So physical address, logical address, and port address. So these things are necessary, mandatory one to identify the node. So here the IP is also a unique one. We have to assign unique IP address to every node connected in the network. So that should be managed by DHCP protocol. How the DHCP is managing that task, we will discuss it here. So IP address, there are two versions. We know that IPv4 and v6. So v4 addresses are commonly used IP version, 32-bit address. In advancement, we have IPv6 also. The address is 128-bit length, right? Okay. If a new computer is connected in the network, DHCP provide with all the necessary information for full system integration to the network. So the system connectivity fully with networking was handled by DHCP protocol. So DHCP using a client server model, we send a request message to a server to which the server respond with an IP address. If the new device is connected, means the DHCP make a request to the DHCP server for getting IP address for the newly connected node. So here, the DHCP server plays a vital role because which is responsible for providing configuration information to the connected devices in the network. There is at least one DHCP server. We can say it is a server as a performing an administration purpose. The server can function just like a centralized repository for host configuration information. And there are its server maintain pool of available addresses, unique addresses, which is allocated for the node, and also to have available addresses for newly connected devices. Okay. So in this diagram, it shows that when the host is connected, it broadcasts a message to the server, which is a request message that is broadcasted over the network. That message reaches the server. The DHCP server responds for the request. So we find the available IP address for the node, and it will send back to the host, which is send a request. Then once the client receives that request response, then it will assign that IP address to that node. So if there is a conflict occurs, if the two or more node utilizing the same IP means there will be possible of IP conflict. That should also handled by the DHCP one. So we can also assign IP address based on the availability. So when if the node is leaving the network, that IP address will be tried back for providing to the other newly connected node. So likewise, the DHCP server and client will work. Okay. So here, so the newly booted or connected node send a DHCP discover message. It's to a special IP address with a 255 point. We know that there are 5 classes of addressing, right? So maximum 0 to 255 range is there. For each class, there should be a certain range is there. So mostly in our laboratory, we are using class C based address, right? So in that 32-bit address, first three bytes are referring network ID, the final 1 byte is referring host ID, right? So this means that the DHCP discover message broadcast a request message to all other connected node in the network. This means it reads by all the hosts and router on the network. The router is also a node, right? Because what are all the node connected in the network, which is capable of sending and receiving, we can say it as a node. Then DHCP use the concept of relay agent. So it is at least one relay agent on each network will be connected. So the relay agent is configured with the IP address with the DHCP server. The relay agent will forward that request to the server. When relay agent receive a DHCP discover message, it unicasts the DHCP server and awaits the response. If the response is received from that server machine, it immediately sent back to the client. So this diagram shows the interconnection between the DHCP client and the DHCP server. First, the client machine send a DHCP discover message that should be broadcasted over the network. Then once it reaches the DHCP server, it responds with the DHCP offer. It will provide certain available IP addresses. So based on that offer, the DHCP client send a request for that particular address. Then if the server respond with that request, so that IP will be retrieved and assigned to the client machine. So likewise, the DHCP configuration is the dynamic configuration is made. So dynamically target the IP address based on the availability. It checked and assigned to that connected node in the network. So that's why we are using DHCP for assigning IP address nowadays. They initially Bootstrap used. So overcome the disadvantages of DHCP, Bootstrap only DHCP is evolved. Okay. So this is the message format of DHCP packet. It's using UDP protocol, UDP, use the datagram protocol in data transport layer. So having operation code, hardware type, and hardware length, and hop count. So which means that hardware length is 8-bit field. It's defined the length of the physical address. So Ethernet normally 6-byte length, right? Then hop count. So to reach that, how many hops with the node the packet should travel? That count will be added in hop count. Then a transaction ID shows that the 4-byte field is an integer ID. It sets the client by based on some value. So normally it is used for identifying the request number. Then number of seconds is a 16-bit field, which means the number of seconds it elapsed to make time the client started to boot. Once the client started to boot and after getting the IP address, how long it wait to get that IP, that time number of second will be noted. And flag, this is 16-bit field in which information about the rest of the bit will be added here. And IP address are the source and server IP address and gateway also added. Then hardware address is a physical address will also added. Server name is mentioned and boot file name is also mentioned here. So the entire header format will have these informations. Okay. So with the help of the DHCP protocol, we can assign IP address, and if once the node is leaving from the network, again the release DHCP release message is used to release the IP address, what kind of address is assigned. If the node gets failed, we can retrieve the address back, and that address will be utilized for another new incoming node. Okay. So likewise, the DHCP will works. Thank you so much.